So cool. So I think today I have 5, right? 5 AP Calc students in my class. So that's so great. And we also have you at home. So awesome to have you all. I'm going to open up my PowerPoint, and then I'll be taking attendance. All right, everyone. So let's go ahead and get started with our check-in. So let's see what today AP Calc's check-in. Okay, what's your favorite shirt look like is the question. Check this out. What does your favorite shirt look like? Go ahead and put that in the chat, and then I'll see who we have here. And then for in presence, feel free. Oh, whoops, I'm sorry, it's like projecting. Well, it's too small, right? So we got, it's a Soul Eater shirt I have had since like 6th grade. Black Nike shirt, like red, yellow Nike. Oh, yeah, the sign logo, that sounds cool. I think for me it would be an oversized, it's an oversized loose shirt that I wear as a pajama. Loose shirt, pajama. We got a red polo. Just a plain old black tee. Those are always versatile. Sunset on it has a sign on it. Small angel feathers on the front and big angel feathers on the back. I've had that shirt for forever and kind of surprised it still fits me. Oh, that looks like a nice shirt. I would love that shirt. Angel feathers. And having it for so long, that's awesome. Oversized, but it's a tie-dye shirt. We have a green shirt. El Pueblo shirt. I don't think I know that one. El Pueblo shirt. And we got one of my sarcasm shirts. I own none of a sarcasm shirt. A pug shirt. Wait, what the heck? Oh, you're imagining that's or is Lolly saying that? Because I could imagine those shirts with the little pug on it. That's cute. Who am I missing here in our check-in? Am I really missing? I feel like I'm missing, so I'm missing Kaylin with the C. Am I also missing, no, Sophia, well, you're the first one that answered. Yeah, I was gonna say, am I really missing Juan? Juan is here. Juan just came in, everyone. So I'm missing Kaylin with a C. Am I missing Kaylin with a K? And I apologize if I missed you. Kaylin with a K. Oh, so Lolly, you're here too. That's awesome. I'm also missing Evie. I'm missing Sofia Pena and Shania. So let me know if there's any error in that. I'm gonna also double check our list. Yeah, so that's what I'm missing. Let me go ahead and put that in. So again, Kaylin, both Kaylins, Evie, Sophia P, and Shania. Thank you all for sharing what your favorite shirt looks like. We got looks all white. It's like a white t-shirt. Awesome. And welcome, Juan. I got you in. And then welcome, Kaylin. I'm going to go ahead and mark you present. All right, we got white tees, black tees, and then some of us have specific t-shirts that are the best. Okay, cool. Let's go ahead and transition, everyone. So our agenda today, so here's what we're doing. We just took attendance. We're gonna talk about FTC part part 1 today after we talk about yesterday's Google form responses. Then we'll have a checkout, and then asynchronous number 10 has actually been posted. That one is due tonight. That one's due tonight. And the mini final, I also posted that too. So just, they're all there. Those are like, nothing else is gonna be posted for this module. So those are the last 2 things. Let me know if anyone has questions in person or online. Yeah. Big problem like we always do are equations. So I think it has a mix of both. And I also have a copy for the in-person folks that y'all I could pass that out too, so y'all can take a look at what the mini final is going to look like. So for Shirley, I think it's probably a mix of both. So I don't think it's exactly like the past ones. It's a little bit different, but then you'll be the judge of that. So yeah, great question. Any other questions coming up for folks? All right, cool. So let's go ahead and move on to our next portion. As a reminder, I already went over this the other day, but the AP Calculus exam is all digital. It's on June 9th. You do not have to take it, but if you do, you have my full support. Again, so because Miss B said it's so late in the year, the fee is fully waived if you do take it. So up to you. And I understand that for the seniors here, it's after our graduation. So that's something to consider when you're thinking about whether or not you're going to take this exam. All right, everyone, let's go ahead and recap on the work that we did yesterday, which was we were just looking at examples on how to do fundamental theorem of calculus part 2, where we took the antiderivative, plugged in, subtracted. That's what we were doing yesterday, and we did a Google form on that. And then I collected data to see where everybody was at on there. Yeah, and then we did like step-by-step examples. So this was yesterday. I just took a screenshot of yesterday's slide, a step-by-step version on how to apply this theorem. And then you had the Google form. And at the end of the Google form, I noticed that there was like a variety of different answers. So we're going to take a look at that today. And I was hoping to, I don't know if you see, there's like an iPad in the room. Like I'm hoping to use the iPad to go over the problem. So we'll see how that works. Here's a picture of someone's solution on the Google form. I like the color coding. So notice their answer, they got 46. That's one student. Here's another sample. This student got 19.75. And so we got 46, we have 19.75. And let's see, I have another third sample. This particular student got 46.5. So actually there was a variety of answers. There wasn't actually a very common answer. So today, my hope is we're going to talk about this and see what is exactly the answer. So one thing though that I noticed when I'm looking at these different samples is that they all kind of have a similar things. Like I see the 2x to the 4th over 4. I see that even behind there. I know I put some pictures in front of it, but I see it here. I see 3 coming up. And then I see substituting. So I see that the processes are there. It's just that we need some help with the arithmetic, the in-between parts, to kind of get ourselves cleaned up is what we need to focus on. So let's do this problem. So here is the problem. I'm going to try to write it on the board. And what I'm going to do is also stop my share. So let me stop my share for those at home. I'm going to stop my share, and then I know y'all can see yourselves. Let me spotlight this. And oh my gosh. That's like an eternal, okay. I cannot minimize when I'm recording. Okay, how do I get rid of this then? Okay, do that. Wait. Okay, what can you all see for those who are in here? Can you see the board? So you don't see this thing? Okay, so it's not that much of a, okay, like that. Okay, you can't see that. Now what I'm gonna do is also, I need to turn off the projection. So let me do that. And then, I don't know how this is gonna work, y'all, so let's see. I'm scared if I pull this out. So give me a second for those at home. I'm trying to figure out how to do this. I don't hear the audio. So let me join audio. I'm scared. Turn this off. The audio. Dial in. No, not that. Okay. Still, see that it's still. Stop doing that. Can folks at home not even? Okay. Hello. Hello. Is it cool here? Okay, I
Yeah, we
don't
can hear you.
understand. Okay, you can hear me, but let me try this and let's see what happens if it does it. Hello? It's doing it now? Yeah, so let me stop. I guess I have to wear this. It's gonna be very hard. Oh my gosh. Okay. So let me turn off my thing. I kind of still feel like I hear the little background noise. And yeah, I think I need to buy some Apple earphones or something. All right, can people in the class help me? Like, what is the problem? If you could go back on, oh yeah, that was perfect. The this one. Oh, so 2x to, okay. If you could read that for me, so the integral from 1 to 3.
In the front, the elements be to the top and move at the bottom.
Okay. So now I'm looking at this. Now, how do I make it so it's not backwards? Do you see how, is it backwards? Oh. Okay. So let's do this. And I'm hoping it's not confusing for the folks at home. Let me just bring this back.
How do I hear my voice? Do you all hear my voice echoing though? Yeah, I wonder how to stop that. What is up with this?
Did you mute your computer?
Yes. What do you do?
Okay, I muted my Zoom as well. So let's see. Okay, hello. Does it sound better?
Yeah.
Okay, so I fixed, thank you. I see Juan, you made a comment. So now I'm on the iPad, so it's a little bit weird. Okay, let's do this, everyone. Let's figure out what the answer is after all of this. And again, let's see. So let me do, I know step 1 is like I originally did like color coding. So I guess I'll do bottom number green. Top number, I guess I'll do purple. Okay, step 1. So I mean, that's step 1, usually color code. Step 2, take the antiderivative of this. So we're gonna take the antiderivative of this. And how we're gonna do is we're gonna plus 1 divided by that same number, and we're gonna keep that 2 in the front. So the 2 stays. Let's go ahead and add 1. So 3 plus 1 is 4. Then we have to divide, and these numbers are usually the same. So as a reminder, the antiderivative rule is, now where can I place it? Where is the rule? there's the rule. So as a reminder, where you're taking the antiderivative, you just add 1 and divide it by that same exponent. So I'm just doing that very same thing. Now, due to the spacing, I'm gonna have to erase it because I had no space, but that's the rule. So that's what we're using. Now, for this last one where you just have 3, you have to imagine that there's an imaginary like x to the 0. So we're still going to add 1. So 0 plus 1 is 1. Divided by that very same exponent is just 1. So we don't usually write divided by 1 or x to the first power. So I'm going to go ahead and rewrite this as just 3x. And I noticed that all those samples had that. So step 1, I took the antiderivative. So here's my original, here's my antiderivative, step 1. Oh my gosh, there's like 18 things in the chat. I didn't see all this discussion. Oh, no, that's from the past. Okay, great. Okay, so cool. We took the antiderivative. Next step is we're gonna go ahead and plug in the top number first, subtract, and we're gonna plug in the bottom number. So let's do that. So for the first one, I'm gonna be using brackets to organize my work. I'm gonna plug in the 3. And actually, everyone, before I plug in, I just looked at something. So I saw this 2 and 4, and I know I could reduce that to ease my work. So it's like, why? Let's reduce the 2 over 4. Someone in the chat or someone in class, what does 2 divided by 4 reduce into? Who said it? 1/2. So that's going to reduce to 1/2. I don't know if I heard Hecka mumbling under the thing, but yes. Right here, and for those at home, 2 divided by 4, you could change that to 1/2. So let's just ease our life. Okay. So that way, we're gonna have less numbers to work with. It's gonna be nicer. So now I'm gonna go ahead and use this antiderivative. I'm gonna first plug in 3, so let's do that. So it's going to be 1/2. I plug in 3 to the 4th power. Plus, don't forget to plug in into the second x, 3 times 4. That's my first one. That's the purple number. You know what? Let me do the brackets in purple. Y'all can see that's the top number. And if any questions pop up in class or at home, let me know. I'm going to subtract. And now I'm going to plug in my lower limit, which is going to be 1. So let me switch my color to my green again. I'm going to be using green brackets. I'm excited to see what the answer is, y'all. This is actually the first time I'm doing it. So I don't know who's right. Let's see. So we're going to again do 1/2. I'm going to plug in my 1. And it's to the 4th power. And then I'm going to add 3, plug in 1. So here's our setup, which I saw many students, their samples look like this. But again, the question is, how do we like reduce this? All right, what in the world is 3 to the 4th power? I wonder. 40.5. Okay, actually there's some stuff in the chat happening. Let's see. So let's see what's going on. It says, wait, why is there a 4 in the 3 times 4? Why is the other one 4? Isn't it 3? I don't know. What y'all think? Y'all agree with the with the students in the chat? Y'all agree that this 4 right here should be a 3? That's supposed to be a 3. So I got yes. How about we got yes, yes? In agreement? Or we have a shrug, so maybe don't know. So yes, this is actually supposed to be a 3. So thank you for those at home. Yes, there should be a 3 because we're plugging in the 3, the upper limit, into the antiderivative right here. So yes, that should be a 3. And I actually am going to just do this. So for those who didn't see that, 3. And this is 1. These should be the same. There we go. Boom. So now, thank you so much, y'all. So now either if you're at home or if you're here with me, yeah. Thank you, Shannon, for trying to clarify about the reverse distribution, the reverse power rule there. So now for anyone at home or here, what's 3 to the 4th power? You feel free to use your phone or, you know, if I know we don't have calculators, so what's 3 to the 4th? That's the one I probably need some. 81? Thank you. So this right here we have just found is 81. Great. This I know it's 9. 1 to the 4th, that's just 1. So that's, you know, just 1. And then 3 times 1. Let's go ahead and simplify all this mess. 1/2 of 81. What is 1/2 of 81? I know that's going to be like a decimal. Or 81 divided by 2. 40.5. 40.5. Thank you so much. Then we have plus 9 right here. Let me just bring down those purple brackets. Subtract. 1/2 times 1 is just 1/2. Then we have plus 3 times 1. We could change this to a decimal too. So this is going to be, so 40.5 plus 9. Great. You don't have to, I mean, I just like to keep the brackets. 3 plus 1/2, we'll just say that's 3.5. That's fine. Now, what do y'all think we get when we do this subtraction? 46, perfect 46. I see nods. Let's see what at home, what do we think? Shannon also says 46. All right, y'all agree. The answer looks like it's 46. So it looked like whoever had the very nice color-coded solution, they had the 46. So awesome. And then if you're interested in looking at that color-coded one, it is on the slide. So we have now figured out what the actual solution is. So this is kind of like helps us with the precision. Let me know if there's any questions at home or in class for those in here. Feel free to put it in the chat. But yeah. What was that? Yay, good job. That's awesome. Wow. Awesome, awesome. All right, so I'm gonna try my best for those in here. I have to go back to my slides. I don't even remember how I did that. So hold on a second for those at home. I'm gonna try to get back into my slides. Okay, mute the other. I thought I did, but I guess I did not. And then I'm gonna turn on the slide. I erase this, so hopefully everyone at home is okay with that. Erase. Let me know if anyone needs me to not. Oh, okay. I'll just see. Oh, but you know what? They got that first screenshot. Student who had that answer, so they can look back. Okay. Now I need to spotlight myself instead of, yeah, that scary stuff is happening there. So let me just stop spotlight here. Hello. Okay, so I think I'm spotlighted now, right? Okay, thank you so much. I'm like, okay, so I'm gonna go ahead and share my screen. And I'm gonna go back to our slides. And great, so I think I'm back. Okay, so yes. Thank you for your patience, everyone at home. All right, I'm gonna go ahead and move us along. So that was funny. Yeah, that was, oh, okay, whatever. So I'm gonna move us on. I had a white blank slide for myself. Okay. All right, y'all. So yesterday, this is where we left off. Remember that? So a lot of you had some questions or confusions like, oh, like, is it okay if I don't get this yet? So this is where we had left off. Apparently, if you take some integral, that's what this is, this little squiggly symbol. If you take an integral from a to x of some function that's defined for t, right? If you do that, you do the same old stuff that we just did, right? Like you plug in and subtract. But what if you take the derivative of that? If you do that, you're going to get back your original function, except it's going to have an x instead of a t. So for many of us, that probably went above our head. Like, well, what in the world is this saying? What it's basically saying is that if you take the derivative of an integral, you get back your original equation. That's essentially what this is actually saying. That's what this is saying. If you take the derivative of, it's basically telling us that they undo each other. That's what this is telling us. So it's okay if you're getting a little bit mixed up with the details in between, but that's the main juice. That's the main essence of what fundamental theorem part 1 is telling us. And that's all we need to actually understand, just the main essence. You're not going to be asked to reapply this right here. So let's see if there's any questions about the main essence. Here's the main essence. Let me type it out. The derivative basically undoes the integral. That's just it. That's what you want to get from fundamental part 1. But if you are interested, like to extend your learning and so forth, you know, you feel free to take a look and try to figure out why this is the case. You could definitely do that as well. So let's see if there's questions about just the main juice of this. And you could try it out, y'all. At home, if you take an integral and then you take the derivative, you'll see that they're going to go back and forth. So it's basically fundamental part 1. All right. And I'm just trying to see if there's anything popping up in the chat for us. Cool. So if there's nothing coming up from this, let me go ahead and take us to the next part. Let me clear my screen. Okay, everyone. So to kind of just make sure that you understand like what's the difference between part 1 and part 2, this is what you would see if you were in a textbook. This is what fundamental theorem part 1 looks like. Notice how there's that derivative symbol, there's your integral, and if you take the derivative of your integral, you get back your original function. So that's the main essence. And then you could go ahead and read the little details about this theorem and this version of the theorem. Part B, right? This one right here, this is fundamental theorem part 2. That's the calculation thing that we just did on the board. That one is actually finding exact areas under a curve. So go ahead and read this because we're going to be doing a Padlet. So take the time to read it. We're going to go on the Padlet. I'm going to ask you like, what's the main difference between part 1 and part 2? Remember, A is part 1, B is part 2. Like, what do you think is the main difference between the two? Based on what you read, based on what I said, whatever, we're going to go ahead and put that in a Padlet in a second. So we'll take a moment. Hopefully you had some time to just read through it at least before we start our little Padlet. We're going to go ahead and jump into that. So what do you think distinguishes part 1 and part 2? I'm going to get that Padlet. I am so happy I tried the board thing with AP Calc. You guys are so forgiving and so helpful. Thank you so much. But anyways, let me go ahead and grab the Padlet for everyone at home. And, you know, probably for everyone here. I'm going to stick it in the chat. So yeah, it's just loading for us, but once it loads, there we go. Look at all the thoughts we've been doing in this module. It's a lot.
What we're doing is A, or we're doing B, we're finding the area under the curve, right? If that's what it was.
So actually so like what we're doing right now is you're just looking at, so A was the one that was just talked about. So that's fundamental theorem part 1. Your B, fundamental theorem part 2. That's the thing that you said, finding the areas part B actually. So basically you're just reading through this and just seeing, like, in your own opinion, what do you think makes these two parts different? So part 1 and part 2 from what you see there. And then, like, if it's confusing, I think we'll have some thoughts there popping up into the chat and we'll see what everyone else is thinking. And if anyone at home on Zoom has additional questions right now on what we're doing on Padlet, let me know. But again, in your own words or your own understanding just right now, even if you're not there yet with fully understanding, what do you think makes part 1 and part 2 different? Again, let me show you. This is part 1. Let me type it in to make sure y'all know which is part 1. This is part 1. Down here is part 2. What does that mean? Why did my external display disconnect? Maybe because I was moving it. Try that. And I'm going to spotlight myself. Sorry, everyone, just my screen share kind of stopped. There we go. We're back on for Zoom, but I'll put it up back up for those who are here. So again, as I was saying, part 1. And we got part 2. So let's see. Okay, let's have some more time to think on this. Let's go ahead and have a little bit more time. See 1, 2, 3, 4, 5, and 6 responses there on the Padlet. So let's have more time. And it's okay if you're like struggling with what's the difference between the two. All right, everyone, let's go ahead and come on back. And let's take a look at what y'all think. So So we have a lot of like thoughts on this. So I think part 1 is used to define new functions under the curve. One is used for the area, and the other one is used for more precise calculations. So one is it's like used for the area, one is more precise, is what I'm seeing. We have A, so part 1 is a new function for area under curve. B is finding the area under curve. Yeah, part 1 only gives the function to be able to get the area. Part 2 lets us plug in and get the actual area. And then thinking is showing us different steps for getting the area. So a lot of you are understanding that, integrals are used for area. We're getting that new function. I see that coming up. We'd have a few thoughts still developing there. And we have that new function coming up a lot. So that's like a common trend I'm seeing here, that part 1 is showing you a new function. But let me go ahead and reiterate what should distinguish these two things, everyone. So the difference between the two, I'm going to go ahead and use the annotation tool, but it's actually not popping up for me. So I'm going to go ahead and verbally do it. Let me guys go ahead and verbally say what's the difference between the two. For some reason, my annotation tool is not popping up at the moment, but the difference is, and let me go ahead and reiterate it. Part 1 is telling us that the derivative undoes the integral. That's what part 1 is telling us in that theorem. The derivative cancels out the integral. That's the main essence. Part 1 is just telling us that. Part 2, the one at the bottom, is giving you the steps to actually calculate area under curve. So part 1 is telling us derivative undoes integral. Part 2 is actually giving you the exact steps that you want to follow to find the exact area under a curve. So that is actually the difference between the two. Usually right now I'll be typing that out, but again, my little annotation tool disappeared at the moment from my screen. So there's where we're going to land. So I'm going to go ahead and take us back to our slide. And we're going to go back down to number 11. Now, actually, I guess it looks like for folks that are here, so I don't know if it's helpful for me to project my screen. I'll ask you all after, but I'm going to try to disconnect it. So let me see if my annotation tool pops back up. I'm going to go back in. Yeah, so I see my annotation tool now, and I do see some comments. It's just, you know what? I think I understand what happened. See, now I can see everything. It's like, I think I don't even need that connector actually. So I think I'm just using AirPlay is what's happening here. Oh, my bad. Someone said, can I repeat it one more time? So for the last one, sorry. Yeah, because I didn't type it right. So it makes it a little bit hard. So let me go back and repeat what I just said. Right here. So let me go ahead and finally type it out because now I can do that here. So part 1 tells us a derivative cancels out an integral. That's what part 1 is telling us. That's why at the end you get f of x, because the derivative cancels this out and you just get your function. Part 2 is basically giving you the steps. Oh, well, it's all in caps. To calculate the area under a curve. So that is the difference between the two. I went ahead and typed it out because it was requested that I repeat that. So there it is for us. I typed it right here and typed it down here. So that's the difference between the two. And for folks here, feel free to copy that down on your little copy. So it definitely helps to know the difference. Like you're hearing calculus, and this is the fundamental theorem. So this is what is calculus right here. And if you're able to explain the difference between that two, that's pretty advanced. You could explain that to, like, your friends, impress them. Okay, so let me go ahead and clear this up. And let's go now to this picture that y'all are so probably tired of seeing always. But I told you all at the beginning of our module that this right here holds the essence of the fundamental theorem of calculus. But why is that the case? That's
Okay, I don't know if you get wrong, but I think part two is gonna help you find, the distance, which is the second graph, I don't know if it's the rate or accumulation graph, I don't know if it's like.
which one, the distance?
Yeah.
Accumulation.
This graph, like, you don't know which graph that one is the rate or accumulation graph.
Uh-huh.
I feel like part two, like, fits into that one, and for the first graph, it's it tells you the derivative comes out in integral.
And hold on, and wait, sorry. So you got part two fits the accumulation, the distance one. And then what was the second part you said?
And then part one fits the speed over time. I don't know if it's right now.
Speed over time, but not sure if right. That's okay. I went ahead and typed it into the chat for sure
It
if
could be
right.
the other way around.
Or it could be the other way around. So I went ahead and typed in an in-person thought about the connection with the fundamental theorem. So they had an idea that part two fits the accumulation part. That's this one here. So basically like distance is accumulating. That's your accumulation. This right here is a rate because it's speed. So saying that part two fits here. And then part one fits this here, but then not sure if that's correct, or it could be the other way around is what I got as an idea. So let's talk about that. So this is the essence. So this right here, if you're able to explain this, it shows you do have like a strong hold on understanding on what we're doing and what is, calculus. So I'm going to go ahead and I'm going to show you once more the connection between the two and how this even relates. So I'm going to go ahead and once more begin this again. So as you know, I always keep doing this. I'm going to shade the area under the rate graph. And for those who are here, like feel free, like if you forget which one's rate and which one's accumulation, you should write it on top of it. So this right here is my rate graph that I'm shading. And if you find, or if you calculate the area under the rate graph, if you find the area of this rate graph, so that's going to be base times height. So then now we're saying, part two, let's find the area. So someone's thinking about part two already, because remember part two gives you exact steps to find area. Love it. When we find the area of this, we get the accumulation, which is the distance. So let me just type that out. Area of the rate graph gives you accumulation, AKA distance. And then remember, there was a way that this distance graph relates to the rate graph. And how it was so is because if we actually take the slope, so 150 divided by 3, that's our slope of this graph. If we do 150 divided by 3, you should get 50. And that is your constant rate over here, your speed. So then I'm going to put the slope of the accumulation graph gives you the rate, which is your speed in this case. So that's how these two are connected. And now let's talk about how it's connected to the fundamental theorem. So basically, fundamental theorem is basically this, y'all. The area under rate graph, y'all, that is your, let me change my color. That is taking the integral. So if I take the integral, I get my area. That's what the symbol means. That's the elongated S. If I take the integral of a rate graph, I'm going to get my accumulation. It's crazy. And then slope. Now, what's slope mean again? If you all remember, taking the slope of something is actually a derivative. So slope is actually you taking the derivative of the integral to get back your original function. Because remember, this right here gave you the integral, your accumulation. But if you take the derivative of your integral, you get back your original. Isn't that crazy how it's all connected? That's why I'm saying this right here holds the essence of the fundamental theorem. of calculus. So let's see if there's questions on that. So there's your connections. Remember, integral means you're taking the area. And when we take the area, you get your accumulation. But if you take the derivative or if you take the slope of this accumulation, these cancel out and you're going to get back your original. So that is like a visual kind of expression of the fundamental theorem. Let's see if there's anything coming up for us in the chat or in person, if there's any questions.
So the rate graph is part one and the accumulation graph is part two?
Actually, there's a little comment there, it's in private, but it's actually like both. It's a little bit of expressing both, not exactly just one. So for example, down there when I'm going this way, I see part one where the derivative undoes the integral down there. And when I'm looking at this, I see part two. So like taking the area into the curve, you're gonna get some number. I see part two on top and I see part one at the bottom. But a student says it's like part one and part two. I also think that could be right too. But yeah, so that's awesome. You're all already thinking about like which is part one and which is part two. And I can't, oh, that's why, it's because I'm annotating. So yeah, so that's my answer to those. Let me know if anyone has any clarifying questions about this. I know I can't get rid of my little chat box. There you go. Okay, cool. So I don't see any questions coming up at home or here in the class. I'm going to go ahead and clear this up. I think it's really cool, the visual representation and connection and how long we took to build this up. We're finally getting some answers. Now it's your turn. So in your own words now, describe how the fundamental theorem of calculus is related to that essential question. And we're going to go back into the Padlet. So I'm going to once more put this in the chat. Now, I went ahead and described that. I drew pictures and, we had some clarifications. There were some questions. But now let's see how you understand it. So in your own words, let me make sure this to everybody. We're going to go back in the Padlet. We're going to go to that next column. Describe the fundamental theorem of how the fundamental theorem of calculus is related to this original essential question that you were asked. How are rate graphs and accumulation graphs related? Basically, it's what I just did in the board. So go ahead and just kind of rephrase your understanding of what you understood from that. And if anyone at home has any questions or clarifications about what you're being asked to do, let me know. But we're on column number 11 right now. Let's take a minute or two. And again, put your name or initial there for your credit. Mhm. I know some of you are still adding in your comments, but I'm gonna go ahead and take a look at what our thoughts are in here, our last 2 minutes. So let's take a look. Wow. So there's a lot of connections. Again, some of you are, I see a lot of resonance on what's going on here. I highlighted the RG in purple here because I like how simply it was stated. The simplicity, the shortness, the conciseness. The area of the rate graph gives you accumulation, aka integral. Sorry, I added that, or the integral. And the accumulation graph gives you, so I would say that's ddx or the derivative. So I like the conciseness of it. But if you all are interested in a more thorough kind of explanation, check out JL's, just in case if you're struggling like at home. But otherwise, everyone's thoughts are definitely on point. So as our checkout today, let's just think about this column number 11. And for those at home, please finish up. For those in here, y'all are free to start packing up. It was an awesome first day. Thanks so much for the tech help, y'all. But yeah, so awesome. Make sure you finish this for those at home, everyone. I'm gonna go ahead and stop my share. I'll be giving credit for today's stuff. Bye. Let me move this. I know this is all in the way. Bye, bye. Yeah, bye, y'all. That was great. I loved your participation today, Rosa. You're so on point. Like, really? Like, wow, you really guided the class. Awesome. Bye. It was so great seeing you. Can't wait to see y'all soon. It was so great seeing you. Y'all enjoy. Oh, I'll take it. I'll make sure I charge. Well, yeah. Yes, for sure. I'll make sure I charge it. Your charge is right down there. I'm like connected to the thing. Yeah, see you. It went pretty fast today, right?
Yeah.
It went pretty
All right,
fast.
Marcelo, have a good day.
Yeah, you too. I'll see you tomorrow. Or I don't think so, huh? But I'll see you around tomorrow. How was it?